Today we're going to talk about vectors. It's possible that the only way you know about vectors is from their important use in certain movies. For example, this one.
Request vector, over. What?
Flight 209er, clear for vector 324.
We have clearance, Clarence.
Roger, Roger. What's our vector, Victor?
Yep, that's what vectors are all about. Well, okay, maybe not quite. There are actually two mathematical objects that we're talking about here. They're called vectors and scalars. The simple idea behind it is this. They're both mathematical objects, like a number is a mathematical object, or an angle is a mathematical object, or a triangle, or a matrix. A vector in particular is an object that has both magnitude, which is a three-syllable word that just means size, and direction, which we usually measure with an angle. A scalar, on the other hand, just has magnitude alone, just size, no direction associated with it. Some examples of vectors would be things like force, velocity, and displacement. Force might be measured in pounds, like a push of 10 pounds up, but it could also be a push of 10 pounds down or sideways, so the direction really matters. Velocity is a word that's often confused with speed, except that it's the speed and the direction, like 30 miles per hour west. If you want to go from Ohio to New York, you don't go at 30 miles per hour west. You have to go east. Displacement means a change in position, and it's also a vector. On the other hand, mass, time, volume, and speed are examples of scalars. Speed is how fast something is moving. So your speedometer in your car is correctly named. It tells you how fast you're going. It doesn't tell you what direction. Mass can't have a direction associated with it. It doesn't make any sense. If something has a mass of 15 kilograms southeast, that doesn't make sense. It has a mass of 15 kilograms. So, and the same thing is true with time and volume. So those are the two basic ideas here, vectors and scalars. To add vectors, what you need to do is place the vectors to be added with the terminal point to the initial point, the arrowhead to the end point. And at this stage, I probably need to mention the fact that vectors are represented with arrows. And so typically you're going to have an arrow that has an endpoint and an arrowhead. So a vector might look like this. That's supposed to be straight. Okay. Down here is the endpoint, which is also called the initial point because that's where it begins. And over here is the terminal point, which I call the arrowhead. And maybe we could label it as vector U. And we put a little vector symbol over top of it, something like that, to indicate what we're talking about. So that's how you add vectors. So if this is vector A, and if I use a boldface letter, sometimes I don't bother putting the arrowhead over top. If I want to add another vector, we'll call it vector B, to vector A, I have to place the endpoint of B on the arrowhead of A. Now, here comes the part where you're adding them. And by the way, this makes pretty good sense. If you think of A as being a 30-foot walk to the east, northeast, and B as a 45-foot walk to the southeast, that's what would happen is the person would start over here at this point and end up over here at this point. But the other way of getting them there would be to draw the resultant, which is also called the sum, by connecting the first initial point to the last terminal point. And so that kind of greenish looking arrow would be the resultant. It would be the sum vector A plus vector B. It's actually just that simple. You could even do a scale diagram of something like this. If you were measuring those, their length with a ruler and their angles with a protractor, you could do the exact same thing with A plus B, measure its length. So for example, if 1 inch represents 10 feet, then if you measure A plus B, you'll find that the sum of those vectors is whatever it would be. The number of inches times 10 is its magnitude, and whatever angle to the southeast, east-southeast, whatever that angle would be its direction. So it's pretty easy to add vectors using scale diagrams. On the other hand, let's suppose we have the two vectors A, B looking like that, okay? And let's suppose we want to subtract the two vectors. Well, the thing you need to remember is an important fact you learned in algebra, and that is when you subtract things, what you're really doing is adding the opposite of the second thing. That is, b minus a is the same as b plus negative a. Make sense? Now the question is, what do we mean by negative a? Well, that minus sign means the opposite of, and clearly the opposite of vector a looks like that. Same length, opposite direction. Now if we add b and negative a by putting them arrowhead to endpoint, we will be getting the subtraction of b minus a. So here's negative a, here's b, putting arrowhead to endpoint, and so if I continue, that is the shortcut. Always remember it as a shortcut from where you start to where you finish. That's negative a plus b, which could also be written as, of course, b minus a. Make sense? Of course it does. So that's how we can graphically subtract vectors. The other thing besides addition and subtraction that we can do is something called scalar multiplication. Now remember, a scalar is just a magnitude. It's just a size. So for example, negative 3a is 3 times the length of a and pointed in the opposite direction. So if that's vector a, see if you can figure out what negative 3a would look like. You got it? Okay, here, let's see if your guess matches it. That's negative 3 times a. You had it, didn't you? Yep, you knew it. So you got it. Okay, now there are some other things that can be done with vectors, but for right now, this is all we need. So we have vector addition and scalar multiplication. So let's try an example. Two displacement vectors. The first has a length of 150 feet toward the south, and the second has a length of 70 feet toward the southwest. What is the resultant when the first vector is subtracted from twice the second vector? Okay. Without the knowledge that we've gained here in this lesson, this would be almost nonsensical. But now we know what to do. First thing we need to do is name our vectors. So let's call vector v the first vector. It's 150 feet south, and you'll notice I gave it both a magnitude, then a comma, then a direction. And we'll call vector w the second vector. That's 70 feet to the southwest, magnitude and direction. And the problem we're trying to do is subtract the first vector from twice the second vector, that is 2w minus v, but we translate that into an addition problem, 2w plus negative v. And we know how to do addition, arrowhead to endpoint. So let's write down the two vectors that we're actually trying to add, that is 2w and negative v. Negative v would be 150 feet, but to the north, opposite direction from south. And 2w would be twice the length of vector w, 140 feet, but in exactly the same direction, to the southwest. So let's sketch them. We'll start by having some positive directions chosen. Oops. Let's suppose east is to the right, which means west is to the left, and north is to the top, which means south is to the bottom. And we draw some axes. So a north-south axis and an east-west axis. So 140 feet to the southwest, that's 2w. We'll just kind of go in this direction. We'll stop right there. And like I said, we could have maybe 50 feet equals 1 inch or something like that. But this is vector 2w. And it has a magnitude of 140 feet. I'm just going to write 140. Now we're going to add to that negative v, which is 150 feet to the north. But remember, we have to start at this endpoint. And so we go straight north, 150 feet. Now that is not vector w. That is not vector v. That is vector negative v. Vector v pointed south. And it has a magnitude of 150. To draw the resultant, we go from where we started to where we finished. And so we'll start here at the origin, go out here in this direction, draw our arrowhead, and there is vector 2w minus v. Terrible v there. 2w minus v. We can find its length by measuring it and using whatever scale we selected to figure out what it should be. And we can use a little protractor to measure this angle to see how far it is from the east direction, or we could find this angle to find out how far it is west of north, whatever your choice is. That's how you add vectors graphically. In another video, I'm going to show you how to add vectors mathematically, and it's in a very, very simple way. You will need to know a little bit about trigonometry, basically sine, cosine, and tangent, and the Pythagorean theorem, but as long as you have those in hand, you'll be able to do this no sweat. Thanks for watching.